actually wanted to give a bit of a context, which we also discussed. And I'll take clue from what was the closing remarks of the last session as well. It's been now 3 years that within the ambit of IMC, we've been discussing about how networks are becoming more intelligent, how operators are collaborating with the ecosystem partners to create more intelligence, better observability, a better experience for the customers. What has actually changed in the last 3 years is not only the scale of deployment, the better understanding of what kind of network opportunities are there, what kind of partnerships exist, what kind of use cases can be built. With Gen AI also coming in and the LLM models being more explored, operators and the OEMs have actually taken this to a completely different level. So every year that I come in and do the session with distinguished guests like yourself, I always have something new to talk about. And when we were doing the preparation session, I think there was a lot of discussion around very interesting use cases. But because we spoke about what has happened in the last 3 years, I'll probably start with, what has actually been experienced by the operators. So I'll probably start with Vikas on because what do you see as the real potential of the advancements that we are seeing in the network technologies, and considering you're also part of the ORAN alliances, you actually lead that, you represent Geo in different forums. How are you seeing the entire implementation of network itself within the Indian context? How are you benchmarking that, and what kind of better use cases that you are seeing that are being deployed by operators, provided by OEMs, and what kind of transformation are you seeing in the last 3 years?
Yeah, thanks, Purushottam. So when you say about the use cases, so primarily all the use cases are based on the 3GPP technology because that's the base. But where does the 3GPP lacks is that they take only the RAN or the core. But building a network is not just a RAN or just a core part of it. To give you an example of the same, like energy saving. We in previous session also people talk about the energy saving. The basic features like carrier on and off, cell shutdown, these are all defined by 3GPP. But what Open RAN or the ORAN as a use case is bringing up, how do we utilize those use cases in much more efficient manner? Every site has a different requirement. And that's where this openness comes into the pictures, and also more dynamically you do the energy saving, the more the power that you save. And that's how you see the ORAN, that it is not competing against the 3GPP or some other technology, but it is like in collaboration with the other technologies and is like more enhancing to that. Another example is that the power saving from what kind of energy sources that it is being used for. Either we are using the solar or we are using the traditional way, or we can use a mix and match. As I mentioned, the network is not just the RAN part, it includes the generator, the panel, solar panel, and the whole ecosystem is there. And that's where the ORAN Alliance not only just building on top of the 3GPP features, but on top of others as a network as a whole. And that's where we try to optimize it. Either is the energy saving, or is the traffic steering use cases that we talk about, or QoS, QoE, or nowadays there's very interesting things coming up. We have this RIC. Everybody knows that in ORAN we have a RIC. But the RIC is now capable to handle not only the one kind of network, but in future it can handle the different kind of the network as well. We have 2G, 3G, 4G. 5G, now 6G will also come up. So we have all those layers of network. And you cannot see one layer in a standalone now. It has to be optimization of each and every layer. And that's where where is mostly need are. In this conference room is a different need. When we go out on the road is a different need, different spectrum, different kind of users are there. To cater all those requirements, all those technologies has to work in the collaboration. And that's where this intelligent part of the rigs comes into the picture, which not only can handle one type of the network, but it can optimize across the layer also.
So because you're saying the last few years that you have been working on obviously optimizing the network, energy efficiency, and also using alternate energy, and also managing the entire network across the different sources as well as technologies is a very important use case that will continue to be relevant in the current context.
Everyone is talking about the energy
Absolutely.
saving.
Yeah.
But as I mentioned, you cannot do it standalone. Only RAN optimize in one
Sure.
part of it. It has to look at the whole as a system. And then you need to optimize it. Unless and until you standardize the interfaces, you cannot do the interop. You cannot buy a solar panel which does not have the interoperability with the system. The cloud is another example where you need to do optimization. Certain
So because if I can just interject, I wanted to give that as a context. So energy as a use case is a very important use case. But I want to now probably shift gears and take a view from Arun. Arun, you had network technology for Nokia, and you've been actually driving a lot of initiatives on the research and development side as well. And obviously, some of the use cases that Vikas spoke about is something that you cover. But you also are seeing transformation in a different era in the last 2 years, which is around AI, how AI is being used in the entire optimization part. So can you throw some light on very specifically what kind of innovation are you seeing? How is AI being used? What kind of actual returns are you able to see and demonstrate to customers, both in India and globally? If you're not able to get something in India, please say that as a challenge. And if you're seeing something very different globally, please mention that as well.
Right. So thanks, Purushottam. So yes, I think we are excited about what AI has to offer, and so I think they were already through machine learning, for example, through our self-optimized networks. They were already based on supervised learning. You can actually predict the traffic, and depending on whether it's too much or too less, turn on, switch on the cell, switch off, and that led to almost 15% of savings in many of the cases that we have seen.
And is that in India, or are you seeing that as a trend in India or also globally?
Now, this is from a global reference.
Okay.
Yeah, but I think the same thing can be replicated anywhere else in the world. That is one part of it. Also, on the self-organizing networks itself, there are exciting possibilities of self-configuring networks, self-automating networks, self-healing networks, and if you take AI and put into all of these things, configuring, planning, verifying, all of that, what used to take matter of weeks with human effort could be reduced to matter of days and even matter of minutes. So that is, I think, where we are seeing a huge benefit. I request all to visit, our stall at, our Nokia booth, and there is one presentation on AI for 6G. I think a lot of promise out there. In fact, AI is going to be part of the native interface in 6G. I think even the standardization bodies have seen the advantage. And there, it doesn't end. You put in reinforcement techniques, reinforcement learning techniques to kind of play around with the load balancing and define what's the proper QoS, QE according to that particular situation. Or, for example, if you look at our, you asked for an Indian reference, I can safely talk about our Nokia Chennai factory.
Okay.
Yeah. So if you want to take out one assembly line and put a new one, yeah, doing it manually would take something like 3 to 4 weeks. Yeah, we've reduced that by 86%. Yeah,
Okay.
thanks to the kind of how we've started using AI along with the other technologies like IoT, automation, and so on. And last but not the least, the rage that generative AI has brought in. And for example, it's a very typical use case to use in care and services, and several other aspects as well: customer documentation, technical documentation support, and so on.
Sure. So we've got energy, we've got customer service, we've got multiple other use cases that Arun spoke about. David, before I come to you, I'll probably like to go to Radhakant because I want to bring. Radhakant comes from a TCS SI kind of a background. We've spoken to an operator, we've spoken to an OEM. I want to get Radhakant here to give a perspective on from a SI perspective. You work with a very heterogeneous OEM ecosystem, right? And there are multiple operators, multiple OEMs that actually coexist. Could you give your perspective on how easy or difficult is it to bring the entire ecosystem together? And now with some opportunities also coming from the startup ecosystem, how are you seeing that entire integration working? And is that actually beneficial for the operator? Are you seeing that trend coming in India? Or is that something that you're seeing globally from your work that you're doing across global companies and which you want to bring into India?
See, first of all, thanks, Purushottam. It's a good topic. See, when it's exciting network, let me not limit to RAN only, right?
Absolutely.
I'll just RAN, core,
Yeah.
transport, everything all together. And standards are actually, I think, all of us as a community, as a professionals, and actually growing further in opening up the stuff. I remember, like, it's 20 years back, it was impossible to even think to connect Nokia's RAN to Ericsson's core. Sorry, I'm naming this, but these are the premium vendors, so we can talk about it. But now it is not there. So, I don't want to name the operators. The work we are doing as a TCS, actually, I'm connecting the entire network to a museum of networks. So we're building everything in our own, and actually it has been very easy for us to really connect to a network which is again 20 years old, 30 years old, and some of them are of very different generations. And it's because the community has become open, and also at the same time, we also, all of us, as a operating in the same network, got a maturity on what the network should behave like, should I do it or not. And when the very beginning stage of your technology development, people tend to do so many things, and only maybe some 30-40% of them are actually useful on a basic business features. Rest of them remains like what if kind of scenarios. Like when we're now talking about this 6G standards and all, lots of what ifs are there. And I am just afraid to say that maybe by end of next year, this time, we'll see some 50% would have gone. Only 20-30% will be there. We actually get into the business ecosystems. So I think Ajay, maybe I'll say the matured 35 years of mobile network learning. I think as all of us as professionals and the ecosystem has developed, and also the big guys who are actually made a build business empire out of it, they have been generous enough in allowing the network to be mobile. So what it says is the ecosystem. The ecosystem is about basically four things: your devices, your RAN, and your transmission and your core. Then we have further divided also. The RAN now, two parts. I'm actually thinking about making it four parts also. Maybe ORAN next generation will talk about four parts of it. We'll make a RF part separate, digital part separate, AI part separate, DUC anyway it is separate, RIC is separate. So you can actually make 5 different Lego boxes and make a RAN. And what it makes actually, again, the theme of this event, future is now. Future was 3 years back, we thought. Now it is now, right? And what is now is exciting. Why it is exciting? Because whatever the journey we have taken hard 3 years or 4 years back, can we build these pieces together? There are a lot of startup. How much time I have?
You can take another minute because I can come back to a follow-up question with you.
Yeah, okay, great. So I'm saying as an ecosystem, we have really made sure initially the startups who thought that we can build it, they're also seeing the challenges, what a big investment or the time of 2-3 years. Typical to build a radio, whatever you do, how many people you bring in, 18 months is typical cycle. To bring it to a stage where actually you can manufacture a small prototypes, not even meeting the economic of scale. So at least to make some 100, 200 radios, you need just 18 months. Then another 6 months of maturity to bring it to a scale. So those ecosystems are coming up, and we are seeing, okay, these ORAN, even though the tall claims so that the people can be attracted, invest and all this stuff, but those tall claims are, at least I would say 40 to 50% of the claims are coming true. Remaining will come. Our goal of like, hey, we'll bring down the cost of 20% on the RAN, not happening now. But at least as a operators, as a buyer, he is getting that benefit because the large OEMs are making their cost at a suboptimal level. So I'll leave it there. So please.
Sure. Thanks, Radhakant. So we got a SI perspective also. Puneet, if I can come to you. You come from a very a background where you already have started integrating, or you've always been integrating with OEMs. You've already always been integrating, building more use cases. You also pioneers in innovation, working with Intel in some of the examples that you have actually shared with us earlier. My question to you is, it's a very difficult choice when you look at customer at the end. When you talk about exciting for whom? Exciting for the customer. And if I take exciting for the customer as a theme and customer at the core, you have different layers that we're talking about. You have the infra layer at the bottom, you have the service layer, the application layer, and then the end customer that gets serviced. From your experience in working across the different genre of work that you're doing across OEMs, what do you see as a real challenge in the Indian context, and at least in the last 2 years that we're talking? Is it a skill set issue? Is it a capex issue? Is it a use case issue? Or is it that there is a lot of impatience that is there with the operators and they are asking for too many things too soon? What is your experience and what is your advice how not only operators but OEMs should tread this journey?
Okay, thanks, Puru, for the question. That's a very elaborate one, and I'm thinking a little bit from a non-OEM kind of a perspective, but bringing in a overall kind of a thought here. I would say that more savings come from more innovation, right? More innovation comes from more scale. More scale comes from more, you can say, investment, and that requires a long-term vision. Now, if we try to actually work out a TCO and a business case on, let's say, 5% of ORAN in the complete network, so that fruit is not going to be visible very soon. Now, if we increase the scale to, let's say, 20 to 30%, that requires more investment. Now, I will be able to innovate better if I have more scale, because I will be able to then incubate all the AI algorithms much more with ease. And like Vikas nicely mentioned about spectrum efficiency. So if I have to utilize the SMO architecture on the different layers of spectrum efficiency, they leave different layers, let's say in 5G itself, then my more network should be actually having openness, right? So I should be able to actually reduce the cost of planning the network, cost of drive testing, building digital twins, building a real landscape in the geography that where exactly the the penetration would be there and where I require the massive MIMO beamforming, class A, class B, and that type of stuff depending on which terrain, whether less dense, more dense, and things like that. There is one challenge which I see as the telco industry missing a Gen AI LLM. Now, that's not something which one particular operator might be able to do. It requires a tremendous amount of effort, something like thousands of data scientists. Data is all there, so data of 3 decades, which the telcos have, nobody else has, so data is all there, and we can have different 4 generations of data put together in CSV files or big data kind of, you can say, storage and try to actually ingest it. And the network engineers who have been doing radio, who have been doing network, ideally they have to be taught Python, they have to be taught AI, because till the time they get exposed to it, they won't be able to think that way. And that's very important, because the different classifiers which are there, defined in Python to really work out, you won't be able to try out the different classifiers and see which one is the best, which is giving me the best accuracy, right? When you get the best accuracy, you know that which one is suitable for which particular use case. QoS needs random forest, logistic regression needs spectral efficiency and dynamic slicing, things like that. So these are things which are actually operator driven because they are the ones who are the best fit to really think that this has to be done. Now coming to the other part, which is the power. Power saving is something which we have been hearing as a use case coming into effect since self-organizing networks back in 2007, 2006. At that time, that used to be a complete different tool, like we have an NMS or like we have an FNO, sell the different models, but there is another way that we can actually achieve sustainability. And now everything is coming in the data center, whether it's CUs. Earlier, we used to have, TRAO and the BSCs and all actually in different location than the IT data center. Now everything is together. So everything contributes to the PUE effectiveness. So if you need to bring the PUE closer to 1 or 1.1 or 1.15, something like that, you need those kind of architectures. Then the blueprints. So we are working with Intel. We have been working with them, whether it's AMD, Intel, Qualcomm accelerators, whether Nokia inline accelerator or Qualcomm accelerators. We test all of those in the core as well as in the RAN. We test all of those. There are blueprints, there are numbers attached to it. They all actually come out after testing with the different generations of Intel/ALD/the accelerators, and then we bring it to the operators. So operators know that that has been tested. If you go for ORAN, you have to cost for the testing cost, the engineering cost, the proof of concept, the blueprints, and the ownership. That ownership ultimately would come on the operator and the big brothers like TCS or like Capgemini, IBM, and the ones who really want to be the MSI. Now, in that also, the choice of the vendors, who will provide radios, who will provide DUC, who will provide me servers, that would still lay with the operator. Whether the operators are ready to take that, because that requires more ownership, that requires more responsibility, and then the intention to scale. The last thing, intent-driven orchestration and AI/ML assisted assurance. These two together give closed loop operation. That's in operation, and telcos have been deploying it since, you can say, past decade, or if not decade, 5 to 7 years, and we have our solutions, service orchestrator, NFV orchestrator, and others. Now that gives you AI logic, and that AI logic is limited to the releases. We test, we get the feedback from the operators, and then we incubate into the next releases. It's not as dynamic as the LLM, so that's something which is one aspect I would leave you.
So Puneet, I do have a follow-up question for you, but I'll probably finish with David and then come to you. On how operators are really handling it. But thanks for that. David, if I can bring you in from a international perspective, and sorry to keep you waiting, because I wanted to actually get a complete ecosystem view of India, the different stakeholders, and I've yet to come to Dr. Krishnaswamy. But if I could ask your view on what are you seeing as global trends? You've heard Vikas's view on how he's actually using it for energy efficiency. You've heard Arun's view. What is your perspective on how is it happening internationally? Are there any lessons that India can learn or Indian operators can learn from your work globally?
Yeah, well, first of all, I'd really like to thank you for the invitation. It's wonderful to be here in India today. So thank you. And I think from our perspective, definitely AI.
If you can hold your mic closer.
Yeah, is that a little bit better? Definitely AI and machine learning are very, very important for optimizing our networks. I think we all agree on that. I think one thing we didn't really talk about, but in ORAN, the integration of so many different partners is complex and challenging. And ultimately, the real killer app in networks is stability. And so I think that's still somewhat of a challenge in ORAN. And I think that's something that we're really, really getting under control. But I think that's been a challenge for the past 3-4 years in ORAN. And as we're moving more towards maturity in our second generation products, I see that really being solved at more of a global level. So that's, I think, good for everybody. So that's definitely one of the things I see. Also, I see in the radios, there's a move away from FPGA into system on chip. And what that'll do is bring down again, that brings down a lot of the energy consumption just as a baseline. And then we can add other AI optimizations on top of that baseline. So in our products, we're definitely moving towards SoC-based radios and away from FPGAs. And I think that'll be a trend in the next coming years. Yeah, so those are some of the things I think are significant.
Thank you. Dr. Krishnaswamy, if I could request you to come in. You come in from a very different perspective where you have spent a lot of time also for the work that we've discussed around optimization, and also you have some deep thinking on how responsible AI can actually need to be necessarily be taken into consideration whenever we actually try to implement AI itself. Could you spend some time in the context of what we've just discussed, that AI is important, data is important. Puneet spoke about the entire ecosystem that needs to get managed. But the crux of it is that for any trust to build within OEMs, it has to be secure. So zero trust is a concept that is very, very important. So from your experience, how easy is it to really seamlessly implement it within a short period of time, achieving the TCO that we spoke about? And also the savings that Arun spoke about, 10 to 15% is savings, a big one. What is your experience in this? Very specifically, taking some examples around optimization, and also where responsible AI is also playing an important role.
Thanks for the question. I think the biggest challenge is the disaggregation that has happened, which has opened up all the threat vectors, a lot more threat vectors than you would have had if these were closed boxes. And so you have to do a proper analysis and then counter it. And zero trust, as you said, NIST has been pushing for that, for dynamic security, in the sense an agent comes into the system, but you verified, authorized, authenticated, but don't let it just be there. And it can become a bad actor at a later point in time, so continuously keep monitoring. So every agent's behavior, because it could change anytime. So that requires, again, AI in security. So we need AI for security. We need security for AI as well. So both work together. For the AI, there are 3 different levels. One is, we have to think about 6G digital twins. We have to think about creating digital twin models for networks to design these applications that will close the loop for optimization. So it'll pump data, and now that data needs to be processed. For that, you need another layer that's actually trying to detect, is there an anomaly, and then trying to take some action. And then after that, you actually go to the application that's actually going to do the optimization. The optimization could be reinforcement learning based. May also have to take care of multiple objectives. People talk about energy savings. You want to shut down a cell. But if you want more performance, you want to keep the cell on. So these are 2 conflicting objectives. And so you need system optimization to come in with constraints to actually take a final decision to actually close the loop. And when we talk about X, beyond all of the different types of networks, I say it's about emerging technology. As we go into 6G, it's not only about spectrum and new protocols and all of that. It's all about bringing in quantum processing, AI processing, cybersecurity, threat resilience, and all of that, and integrating all of that into the system. So, we have, and then the main thing actually is heterogeneity. In the previous session, people are asking why ORAN, and what it has done is it has created observability, and that with that observability you can control the network as well. Now, we have legacy networks. Most of the networks are already deployed, which are not ORAN compatible. What we have to do as we get the FCAPS data is to build an adapter that will actually transfer the data to the SMO, so you can do a joint optimization across the technologies, right? And therefore, you need a heterogeneous RIC at that point that works across networks, and this is the direction to go with the information that's there and the distributed intelligence that we have in the network.
But Dr. Krishnaswamy, if I can just add a question to you as well as to Puneet. So in my experience, what is really happening, at least from an Indian context, is you have this heterogeneous infrastructure that is coming through. Operators are not able to automatically implement some of the optimization. They have observability layers, they've got platforms, and some of them have 30 to 40 different applications that they would have actually brought in and integrated over a period of time. So observability obviously becomes important, but at the same time, to get in the actual optimization going on, they are not able to correlate, since they have come in from a brownfield kind of an integration. They are not able to really discover the real source of the problem. Okay, so human in loop continues to become very important. So optimization actually becomes a far-fetched goal, which they are not able to solve for. So in my experience, some of the operators are using the concept of service reliability engineering, SRE, to further optimize over a period of time. They're trying to also build workflows to actually further optimize. Any experience that you have in actually systematically taking an operator to a different maturity when it comes to optimization? Because what we spoke about here was an ideal situation, but actually we don't have that ideal world in the real context, right?
So I was at Geo before this current role, and we had network data coming in, and you know, we started looking at how to dynamically learn what's going on and then adapt. But the thing is, as you said, okay, you can observe, but the controllability hooks are not there. So we have an optimizer that will take a decision, but then the final decision actually has to be done manually.
Correct.
Somebody has to go turn off the cell.
Exactly.
Do that, right? Unless you have the programmability. So yeah, in some cases you don't have control, but we have to start thinking about that. How can we expose some minimal amount of controllability as well to actually make that work? But and the heterogeneity part also is very interesting because we have moved from, say, FR1 to FR2 and now FR3, which is between FR1 and FR3. So the cells that you turn on, they have different radii, right? So, previously if you had a deployment, you would have this hexagonal, nice deployment, you would have done your network planning. But suddenly now you're infused with little small cells, and which do you keep on and off? And that's why you have this joint optimization that's going on. And but one good thing about this is that the small cells that are coming on are operating at a higher frequency in 5G, and the larger cells were actually 4G. So the things that you're going to turn on and off are actually controllable, right, if you have ORAN support on it. And you can keep the macro cell on 4G still on, providing coverage. So there is a blessing there that if you're going to control, and maybe you can work with the portions of the network that are actually controllable to actually still optimize the network, even if you are constrained by it. And I think you were also talking about AI related, we're trying to be, being safe with respect to AI as well. I forgot to answer that, but...
No, but that's I can actually ask another question relating to this, and anyone can actually raise your hands for that. Puneet, do you want to answer?
I just want to continue just
please.
a small example. So yes, as the session is about exciting networks, I just want to switch topics and take the audience to actually transport plane. So that's something which is more deterministic, doesn't require any spectral efficiency, and doesn't have any foundations of the 2G base station, not having an open interface. Otherwise, how will you actually have the spectral efficiency, trigger into the on-air interface? But when you talk about the transport network, so you have the Yang models, you have the open architectures, and there the complete FMS architecture, whether it's the fault management or the performance management, that has been actually achieving some kind of maturity. A typical example, I'll just give you an example. In one of the networks, one of the clients, many years ago, we had a particular issue that the international in-roomers are not able to latch onto the VLR. VLR or, the VSS, whatever, the 3G or 4G. It was not 5G then. So now everybody was actually, trying to see the traces of the, individual mobility architecture components, whether it is a switch, whether it is the 3G UMSC, or whether it is the UMTS, or whether it is, if it was 4G, it was 4G, right? Or the radios. They were not able to decipher what's the issue. But just because we had implemented the assured AIML-based architecture assurance along with the intent-driven orchestration, which gives at a closed loop control. And closed loop means that the service should not be effective. The service is effective. Then it will say that which resource orchestrator is having an issue in the completion of the service. And then we know that where to go. So we found that an optical fiber link which connects India to that country is having an issue.
Sure.
Just an example. So these kind of things have been implemented. When we talk about, having spectral efficiency across 2G and 5G, it's a little bit far-fetched because all of them are not cloud native.
Absolutely.
5G has cloud native, so it's much more
So it has
actually
to be hybrid, for
resilient.
sure.
Even in cloud native and virtualized, you have a challenge, to make sure that you are able to actually have the application working seamlessly across VNFs as well as CNFs. So speaking more practically, I'm just giving you an example.
Thank you. One other challenge that I have been discussing with a lot of network planning teams in operators is they all see the value of Open RAN. They always see the value of actually having a heterogeneous ecosystem. But they say that we have the right intent, we want to do it. We also know that having a multiple OEM ecosystem will give us the best experience. But we don't have an end-to-end capability in actually integrating it. You need multiple OEM teams to actually do it because they know the entire. So you don't have a master architect who actually understands all the technologies and integrate it. Any experience that you can share, and it's open to anyone, where the operators have come back and say that I have the right intent. Can you work with my team to build in that entire ecosystem?
A very pertinent question, Purushottam. So Nokia has taken a lead in this, and we have actually set up two Open RAN testing and verification centers. So one in the US and one in Europe. So where we've invited all the other vendors, and we've invited, for example, taking the radios from the new radio makers, the different vendors, along with us, and specifically tried working on some use cases, whether it is gaming, whether it's network slicing, and so on. I think we need more of these. Yeah, I think
maybe
more of these we need.
I mean, I may be completely wrong here or out of turn, but maybe some of the other industries, like the financial services industry with the open API architecture, is further integrating a lot more ecosystem players within the ecosystem. And telecom and the entire ICT sector has more potential, but the kind of integration that we are actually seeing may not be up to its full potential in some countries, especially India. Do you think that that kind of phenomenon is there, or are we seeing that change completely?
Just one point before, because again, I'd like to invite all of you to visit our Nokia lab. So we have, one demo on 5G, and a very fascinating, new application where it's content-aware, data. So, for example, you're actually taking a video of, traffic on the street, but you're only focusing on the people. Yeah, and because you want to track them, and you can actually leave away all the traffic moving, the cars and so on. So I think for cases like compliance, for public safety, I think those players can actually come into it. Some of the cases
Sure.
that you mentioned.
Because do you want to add anything?
Okay, I think as we grow along with the industry of the telecom, we started just the voice.
Yes.
Then we added data. When we added data, initial use cases was Facebook, and then WhatsApp comes, then YouTube comes, then now all those applications start coming. So when more and more technologies come into the system and the use cases come into the system, there is always a potential that the other kind of industry will also be joining to the network ecosystem. And that will bring lot of innovations around it. I was talking to 3GPP chair, and he was saying that we are just not the network now. We are like the oil companies are part of it. The satellite companies are part of it. And NTN is one of the biggest example which 3GPP is adopting. So
It's
not
a protocol
only
by itself. It's a standard by
yes,
itself.
so as you mentioned, the financial services is one of the example. We in India, we have seen what the UPI can do.
Yeah.
And that brings a more requirement to the network. And is like a chicken and egg problem. Which use cases and what the network can support. So
Puneet alluded to the telco LLM kind of a concept where I think the thinking has already started. Customer service, customer facing operations,
Yeah.
marketing, and some of these use cases that are very, very specific from an operator context is very much the need of the hour. The problem is data.
That is happening. That is happening on the network side, core network side. It's not
Yes.
yet happening.
Yeah. So I'll like to open this up. Any questions from the audience? Anyone who'd like to ask a question? Yes. Could you hand over the mic?
Hi, I'm Chandrasekhar Pandre. Purushottam, you rightly asked pertinent question that all this exciting network, who is excited, and particularly the Indian context. So we have been talking about AI as one of the trigger point for that. Generally, if we have been talking to the most of the leading OEM or CSP, what we come to know that they think AI is not going to help us. The reason being, we know what is the problem in my network, particularly in India. Basically, I have a problem of power cut. I have a problem of fiber cut. So will this kind of AI technology can help them or change the scenario in Indian context when we are talking about migrating from current legacy to AI based, particularly in access layer? Probably in the core, it will be still better, but access definitely a very, very big challenge. So any different opinion from any of the panels? Thank you.
We have to think of AI as a friend. Yes, we have been doing things, but when there is an additional tool, and as we think about X as bringing in additional capabilities, AI will really help. When we think about digital twins, we have to think about 6G digital twins or for design, and then 6G digital twins for operations as well. During design, we'll try to come up with a model that will drive a model of the network, then you can build the algorithm and see if it'll work. But then in operations, you've got to refine the model and then make it more realistic. And as the data comes in, suddenly, for example, there's an accident on the freeway or there's a cricket match, an IPL game starts. So you will start predicting the amount of resources that you need dynamically, and you can predict a much larger window with an LLM because the context window is long. You're not just predicting the next value, predicting a sequence of values. So if you visit our 6G Innovations Lab, you can see that work at CDOT. And then we have to be careful with AI as well, and so we have to think about risk. The more resources we allocate, we lower the risk. For example, we use an LLM with a large number of parameters, or we have a quantization level which is higher, then we use more resources. We reduce the quantization level, we reduce the number of parameters, then the risk goes up slightly. There'll be a balance, whether you use a 70 billion parameter or 13 billion or 7 billion, and we may say we'll use a 13 billion parameter of 4-bit quantization, and that's good for the edge and things like that. And so we have to balance the risk. The risk is a decreasing function of resources, and we have to use AI in this context, with the benefits that it offers, and also be safe with it as well.
I think, Dr. Krishnaswamy, I think the context is also, and because you can also probably add in, context
I would like to answer him. So here's a very pointed question. Okay, how do you is AI is exciting? AI is not exciting in Indian context, or it's not only India. Many other countries, power is a big problem. Even Europe also had a big problem now. How do you predict there's a power failure? What you can do about it? And how can you predict system failures? So there are 3 angles to it, how to handle with the AI way. One is build part, another is operate part, another is enhancement part. Build part, there are a lot of things were experimented. So the telemetry, how granular you can generate. Can you generate in each of the chipsets? Can you generate in your BMC board? Can you generate in the digital part of it? A lot of it you can generate, and you can actually get 20% of headroom on your CPU designs, you can always do the AI-based predictions or managing the health of the entire radio BV unit, RF unit, and all those digital narrow unit you can do inside. And imagine if somebody is thinking, like I'll get all this telemetry data all the way to data center and I'll do the predictions and do the processing, I think future will not be exciting. We'll find out some other future, right? You have to do it on the edge. So you have to really use that particular RU or maximum in the DVCO side. You have to do the processing there, find out the intelligence, only take the outcome data and do a staged processing.
Sure.
So we call it a donut based. Then second part is the operating part. See, one is that bet. I think other than one operator, everybody has some battery. It could be 1 hour, it could be 20 minutes, it could be 4 hours. We always think for 8 hours, then 4 hours, then finally end up in 2 hours. How can I deal? Because this 2 hours is my emergency situation. So AI helps a lot to reduce the power or increase the adjacent cells to really manage into it. Or from an AI perspective, you can find an MTBF of the hardware and actually make sure that where that logistics perspective spare part is available, make sure that somebody, we can actually book Uber to really send that spare part there. There are a lot of ways it can be done. So Chandra, to your question, there's a lot of things AI can do to manage the operate part. Build part is already there happening, and Open RAN is actually helping that a lot. We, in fact, in person have experimented on it. Enhancement, there is a lot of things. When you see the typical behavior, even in the India is so versatile, we do see the people in the down south in the Kochi, the way the networks behave versus in the north in Jammu, Kashmir, Ladakh, or Punjab is very different. And Open RAN gives us that opportunity to actually structure it accordingly.
Because you have a closing statement.
Yeah, so what I will do, I will add up something to the future glimpse as well, where the AI can be useful to the normal human being. Because unless and until it is useful for the normal human being, any technology does not make any sense. We are writing one research paper in NGRG, and I am the co-leader of RS01, which takes care of the use cases. A very unique use case that is coming up, which is related to the Gen AI, is that online language translation. So you don't have to speak in one language so that other can understand the same language. Over the phone, let's say your mother is talking in Kannada, the other person can reply in Hindi, both can conversate with each other. That's the future of use cases where the generative AI can play a major role for the end users. So AI is going to come in a big way, not only in telecom, but in other fields as well. And is going to be helpful if it is used in the right way. Yeah, thank you.
Absolutely right.
I'll just try to answer your question on power cuts. See, telecom network, or whether it's access, edge, whether it's core, it's on backup, right? It's not something which is directly a grid supply going there. Now, what has to be done, like we get SMSs from BSCS, the power supply will be down in your area. We do that, right? So there is an AI engine, there's some analytics that is running out there. This is a power cut is actually a grid problem. It's not a telecom problem, but the telecom operators can get the information in a different bit open APIs format from the grid and then make sure that the consumption of the cells in that area is reduced, and that is something which AI can do. Just trying to answer your exact question on power cuts.
Thank you, Puneet. Yeah, okay.
I just wanted to add to Vikas's example. He talked about applications, but Vikas, even in operations, right? Maybe the resolution comes in English, and the tower operator speaks Hindi, and the message saying turn this thing off can be converted through LLMs, and can just be a voice flow all the way. So we just use AI to help us as much as we can. So.
Yeah, definitely, AI has the power, no doubt about it. I was just wondering about the access part of the telecom, but thank you very much.
Sorry, we are short of time. But I just wanted to say when I was given this topic and it was part B, I thought there is part A and then we'll have nothing to discuss. But as you would have seen in the last 1 hour, some of the discussions and examples that we had were very different and unique as compared to what we had. And that's the advantage of having such an experienced panel that we had. And thank you very much for the participation as well as some of your sharing your experiences. It's been a pleasure to moderate the session. Thank you.
Thanks, Puru.